Hello, linear algebra student. This video is chapter 2.3, part 3. Okay, we're going to continue look at using the inverse matrix theorem to do some conclusion. So E, if there is a B in Rn such that the equation Ax equal to B is inconsistent, that means you cannot find at least one solution in Ax equal to B, then the transformation is not one-to-one, which is true, right? Which is just the opposite of the fact that Ax equal to B has at least one solution, right? At least one solution for each B, and then it would become one-to-one. So if one of them is not true, then they're not true. So G it is based on so this would be force. Oh, well, actually, this is true, right? Because this is true because it's F and G, the negation of F and G. F, if A is invertible, then the columns of A inverse are linear independent. So this is explain why. If because A is invertible, so that means A inverse is also invertible, right? Why do we say A inverse is invertible? Because A inverse has a inverse that because its inverse is A, right? Because its inverse is A. And so A inverse itself is invertible. You can apply it to IMT. So that means A inverse columns are linear independent. So so that would be A for A inverse 2. And linear independent is what? Is it E? I forgot. I think it's E. Yeah. So E for A inverse. Okay. So now one useful things of knowing that a matrix is invertible also, and it links to the fact that you can use A as a linear transformation standard matrix, right? So we would have something called an invertible transformation, right? So if I have a linear transformation and we say that this transformation is invertible such that I have A in another function S, so that t of s of x is the same as st of x is equal to x, then s is known as the inverse of t. So kind of like the inverse function that we talked about in a just a general function definition. So so how do I define this s function, this S transformation? So it turns out that this S is also a linear transformation, and also S of x is just A inverse. Okay, and it is the unique function. So example 1, so if I have a transformation x1, x2, and I can write it like this. So what is the standard matrix of A, of T? So let's write T of x1, x2. I like to write it like this. And that would equal to 2x1 plus x2, and then negative 3x1 plus 13x2, and you can immediately see that this just imply this is actually equal to 2, 8, negative 3, 13, kind of like the um, system's equation, right? x1, x2, because the way we do it would be we would look at x1 times a, yeah, we would look at a row times column. So this times this times this is the first one, this time this time this is the second one. So this is our standard matrix A. So the T inverse will have the standard matrix A inverse. So find a standard matrix. So that would be 2, 8, negative 3, 13 inverse. And because it's a 2 by 2 matrix, we can actually calculate it. First of all, calculate AD minus BC. So it's 2 times 13 minus negative 3 times 8. So that would be 28 plus 26 plus 24. So that's 1 over 50. And then the matrix itself is switch the diagonal and then the opposite the other diagonal. So will be 13 over negative 8. Okay, 3, 2. Okay, so this is the inverse. So if you can multiply it, and it will be like this. So this is 3 over 50 and also 250. So this is the standard matrix for T inverse.